So in the last class we were talking about the three-phase transformer, and I have already shown you, given you details about the advantage of a three-phase transformer, and I have told you that there are 6 types of connections are being there in which the primary and secondary of a three-phase transformer can be connected. One is your star-star connection, another is your one is star-star connection, another is delta-delta connection, third is star-delta connection, fourth is delta-star connection, fifth is open delta or V connection, and another is Scott connection, also known as T connection. And we have taken first of all the star-star connection. Okay, very clear. The primary is also connected in star. Star means the one end of all the 3 windings are joined together, and that joined together point is nothing but your neutral. And similarly on the secondary side also you can see one important thing I have told you, that this neutral of the windings of the 3 phase is always connected to the neutral of the generator. Generator means this is to be supplied by 3 phase. These 3 phase are designated as RYB, red, yellow and blue, and there is also one neutral point. So the neutral of the star winding is always connected to the neutral of the generator, and generator is always being grounded. Generator is always being grounded. Is it clear? So it offers many advantage of grounding, of connecting with the neutral. It allows the magnetic current to pass through it. Otherwise, it will cause a damage to the windings. Then I have already told you that in case of this phase voltage, in case of star connection, phase voltage is 1 upon root 3 times the line voltage. Is it clear? Also, the advantage is very clear, that since phase voltage is 1 upon root 3 times the line voltage, insulation requirement is less. Is it clear? Then winding can carry heavy current because line current is equal to phase current, and thirdly there is no phase shift between primary and secondary because both are connected in star net form. Disadvantage, that this method can be used only for balanced load, not for unbalanced load. Then next come the delta-delta connection. From the picture it is clear that winding of both primary and secondary are connected in the form of delta form. So what you conclude, that phase voltage is equal to line voltage, but the phase current is 1 upon root 3 times the line current, just opposite from voltage current point of view in case of a star. Clear? This is clear or not? This diagram is clear? This is delta because triangle it looks like. What is this? RY, those who could not understand, please, RYB is the line voltage. Similarly, YB is the line voltage, and DR is also line voltage. And fortunately, the line voltage is equal to, what is phase voltage? Voltage between 2 ends of the winding. And what is line voltage? Voltage between 2 lines. So whatever the voltage between RY is the voltage across this winding. Whatever the voltage is there between R and B is across this winding. So, and similar is true for whatever voltage between Y and B is the voltage across this third winding. So phase voltage is equal to line voltage. Phase voltage किसके बराबर होता है? लाइन वोल्टेज. लेकिन मैथमेटिकली हमने प्रूव कर दिया लोअर क्लासेस में कि जो लाइन करंट होता है वो क्या होता है? फेज करंट का रूट 3 टाइम्स, या दूसरे शब्दों में फेज करंट इज इक्वल टू क्लियर, फेज करंट लाइन वोल्टेज का 1 अपॉन रूट 3 टाइम्स होता है. क्लियर? This is the phasor diagram of the voltages on primary side. This is on the primary side and this is on the secondary side. You can see that there is no phase shift between the line voltages of primary and secondary side. Also there is no phase difference between line voltage and phase voltage of primary and secondary. Is it clear? What about the transformation ratio? Okay, the transformation ratio is K, then what is K? Phase voltage upon phase voltage of secondary upon phase voltage of primary. Then you will find that the line voltage is also having the same relationship, that line voltage of secondary is equal to K times the line voltage of primary. The same is true for the your star-star connection. So what are its advantage? The disadvantage of the star-star connection became advantage of this. Kya? That cannot be used for unbalanced load. Even if the load is unbalanced, the three phase voltages remain constant. Yes. Okay, zoom. Now clear? Okay. So this is, I think so, clear, this diagram. Okay. So the advantage, even if the load is unbalanced, the three phase voltage since remain constant, and therefore it can handle the unbalanced load. Due to delta connection, phase voltage is same as line voltages. The reason behind it, that why it can handle the unbalanced load, because voltage remain constant, and why voltage remain constant, because line voltage is equal to phase voltage, and however the phase current is 1 upon root 3 times the line current. So what is the disadvantage? Because neutral is not there, therefore neutral is not there, there is no neutral is there, therefore because of the absence of the neutral, this system cannot be used for distribution system. Distribution में हमें क्या चाहिए? फेज भी चाहिए और न्यूट्रल भी चाहिए, but no provision of neutral is there. Okay. However, the distribution transformer which are used in our colonies, okay, you will see on the primary side the windings are connected in delta. On the primary side the windings are connected in delta. The distribution transformer, for your practical knowledge point of view, you know what is distribution transformer? What are that? The one transformer which are there in your colonies, mohallas, is it clear? That is called distribution transformer. It has also two winding, which name? Primary and secondary. The primary is connected in delta, because the primary purpose is only to supply it, not to distribute it. So it is acting as a transmission line. Okay, so definitely we can go for delta, but the secondary voltage has to be distributed to different households. Is it clear? So there should be one phase and one neutral. So it is always the secondary of the distribution transformer you always find in star. So you will have 4 wire system. On this how much? 3 wire. On this how much? 3 for phase and 1 for neutral. Okay, and I have already told you one practical given observation, that you can identify high voltage and low voltage by externally by observing the bushings. The heavy bushings or the thick bushings are of HV side, because insulation is being decided by what? Voltage. Insulation is decided by voltage. Higher the voltage, higher will be the insulation. Okay. Now you can see that the 33 kV line or the 11 kV line which is coming, okay, only one disc will be there. But if you go to the highway line, if it is 132 kV line, you can easily identify, multiply 11 by 12. It will come out to be how much? 132. So there will be in fact 12 discs will be there, disc type insulator. Have you seen this type insulator? A brown color disc type insulator. So if there are 12 in number, you can easily identify these are of 132 kV line. And if it is are of greater number, then it can be of 220 or like this. Clear? So not suitable for 3-phase 4 wire system. Clear? Next connection comes star delta, very clear. The first name indicating primary side, the second name indicating secondary side. So clear, the primary will be connected in star, you can see it is connected in star, while the secondary is connected in delta like this. Clear? So again, from name itself you can infer what you will find, that first of all, what will be there? There will be a phase difference between the line voltages of star and of primary and secondary. Clear? देखिए, आपस में phase difference होता, that is different thing. Mind it. Keep in mind. In star connection also, you will find there will be always a 30-degree phase shift between line voltage and phase voltages. मालूम है ये चीज क्या? ये स्टार साइड है, तो इसका आप देख सकते हैं, ये क्या लाइन वोल्टेज है, ये क्या है फेज वोल्टेज है, इसलिए दोनों के बीच में शिफ्ट कितना है 30 डिग्री. ये तो होगा ही होगा. हमें, मैं इसकी बात नहीं कर रहा हूं, मैं किसकी बात कर रहा हूं, यहां लाइन वोल्टेज कितना है VRY, ये लाइन वोल्टेज कहां है VRY. ठीक है, इन दोनों के बीच में कितना डिफरेंस होगा 30 डिग्री का. देयर इज अ फेज शिफ्ट ऑफ 30 डिग्री बिटवीन लाइन वोल्टेज ऑफ प्राइमरी एंड लाइन वोल्टेज ऑफ सेकेंडरी इन केस ऑफ स्टार डेल्टा कनेक्शन. सो व्हाट विल हैपन? What will happen? So such type of transformer cannot be connected. While before giving to conclusion, what is the phase shift between the line voltage of primary and secondary in case of star-star connection? 0 degree. What is the phase shift between the line voltage of primary and secondary in case of delta-delta connection? 0 degree. Suppose you have a transformer which is connected in star-star. Okay, you have another transformer which is in star delta like this. Can you connect in parallel? No, because of this phase shift. How much of phase shift? 30 degree. Circulating current will start flowing it, that will cause damage to the windings. So generally these types of star delta or delta star cannot be connected in parallel with the star star or delta. You got my point? So very clear. The transformation ratio is how much? Phase voltage of secondary upon phase voltage of, it is K. So what you will find, the secondary line voltage is K upon root 3 times the primary line voltage. Mind it, this relationship very easy, simple, you can derive it. Is it clear or not? So the primary side is star connected, hence what advantage you will get? Fewer turns, number of turns are required, and this makes connection for large high voltage step down power transformer. So such type of objective question can be asked in your interview questions or in Viva Voce or in your the so called computer exam. What is the use of step? So for balanced load we go for delta connection. Okay, or in fact for unbalanced load only, unbalanced load we go for delta. For balanced, star. For large high voltage step down power transformer we go for star delta connections. Okay, so further on the star connection neutral is available, therefore to avoid the distortion we can use this neutral, because these third harmonic component, they provide path to the third harmonic component. If for example in delta, if the path is not provided, if path is not provided, what will happen? What will happen? They will distort the waveform. They will distort the waveform. It can damage the winding also. And because secondary is in delta, therefore large unbalanced load can be handled satisfactorily. This is the advantage. Disadvantage is what there? Ki the secondary and primary line voltages have a phase shift of, जो प्राइमरी लाइन वोल्टेज होता है और सेकेंडरी लाइन वोल्टेज होता है उसमें फेज शिफ्ट कितना होता है 30 डिग्री का. तो इट कैनॉट बी ऑपरेटेड इन पैरेलल विद आइदर स्टार स्टार और डेल्टा डेल्टा ट्रांसफॉर्मर. अरे समझ में आया कि नहीं आया? इज इट क्लियर? द नेक्स्ट, द फोर्थ कनेक्शन इज विच टाइप? डेल्टा स्टार कनेक्शन. वेरी एज द नेम क्लियर, प्राइमरी विल बी इन डेल्टा लाइक दिस. Clear? And secondary will be in star. Very clear? Again the same theology. What is between there will be a phase shift of 30 degree between primary line voltage and secondary line voltage. Okay, this is very clear. And where you go for this type of connection? Delta star. That is very clear. I have already told you in distribution transformer. Is it clear? Primary is in delta and secondary is in star, because we have to distribute the line, therefore a neutral is required. So on the secondary side there will be 4 wire system, on the primary side there will be 3 wire system. Again you will find that the secondary line voltage is √3 times √3k times the primary line voltages. Clear? I will provide you all these notes on the Google Classroom. So again, on primary side, due to delta connection, winding cross section required is less. Why? Why? The cross section of a winding is decided by current. As I have already told you, just I have given you some practical aspects of the wires one day in the class, that the wires are selected according to the current capacity. For example, in your this fan, tube lights, which wire is comfortable, of what cross section? 1.5 mm square. 1.5 mm square. For heavy loads like geyser, you may go for 2.5 mm square. Even for bulbs, small bulbs, fluorescent bulbs, you know, you were previously using in your household. Nowadays LED bulbs are there. You can go for even 1.0 mm square. But in general, since we have one type of wiring also, so for all fans, tube lights, we go for which type of wire? 1.5 mm square. For geyser we go for 2.5 mm square. Okay, or for refrigerator like this. Okay, and for AC we go for 4 mm square. And for distribution board, which is coming from meter to your isolator, okay, you go for 6 mm square. And for the one which is coming from your live wire, that is the distribution pole up to your meter, we generally go for 8 mm or 10 mm square. You got my point? Okay. So how this mm is increasing? What factors is increasing it? Current. It is the, so when I say mm square, what is mm square basically? It is a cross section of the wire. So cross section of the wire increases with the current capacity increases. So here line current is equal to phase current. Current is same. Okay. However, star connection, the line current is root 3 times the phase current. So if you compare from the star, okay, the cross section of delta will be less or star? Delta. It will be delta, because there it has to handle the line current. Okay, here the line current is equal to phase current. So winding cross section area required is less. On the secondary side, again what happens? Because delta star is there, neutral is available, therefore you can go for distribution of supply. It can be used for 3 phase 4 wire supply. कई घरों में आजकल 3 phase supply यूज हो रही है, AC यूज हो रहे हैं, तो हर फेज में एक AC. So हर फेज में एक AC means you have to go for 3 phase 4 wire system. Or if you are having light loads only, then you can go for single phase, that is 2 wire system, phase and neutral. Now there is no distortion due to third harmonic component, because path is being provided by the neutral. Is it clear? Now this was the advantage on the winding side. डेल्टा का एडवांटेज किधर होता है? वाइंडिंग, लेस क्रॉस सेक्शन एरिया ऑफ वाइंडिंग इज रिक्वायर्ड, तो कॉपर रिक्वायरमेंट इज लेस. स्टार का किधर फायदा होता है? इंसुलेशन में. इंसुलेशन किससे डिसाइड होता है? वोल्टेज से. इंसुलेशन लेवल किससे डिसाइड होता है? वोल्टेज से. तो इंसुलेटिंग मटेरियल कम यूटिलाइज होगा, क्योंकि हमें इंसुलेशन किस पे लगाना? फेज वाइंडिंग पे. और फेज वाइंडिंग पे वोल्टेज कितना होता है? लाइन का √3 टाइम्स. इट इज and since secondary is in delta, therefore it can handle a large unbalanced load. सेकेंडरी किसमें? मैंने एडवांटेज नहीं बताया था डेल्टा डेल्टा कनेक्शन का, कि डेल्टा डेल्टा कनेक्शन कैन हैंडल अनबैलेंस्ड लोड, वाइल स्टार स्टार कनेक्शन कैन नॉट हैंडल अनबैलेंस्ड लोड. तो चूंकि हमारा सेकेंडरी किसमें? डेल्टा में, देयरफॉर इट कैन हैंडल दी लार्ज अनबैलेंस्ड लोड. अरे क्लियर हुआ कि नहीं हुआ? अगेन what is the disadvantage? There is a phase shift between the primary and secondary, and of how much degree? 30 degree. Therefore again this cannot be connected in parallel with the star star or delta delta. Is it clear or not? Now this is a table, visible? This is a simple table which is elaborating everything, the voltage, current and transformation ratio. Okay. For example, if I take star star, line voltage is VL, phase voltage became, phase current is IL, and therefore phase voltage will be how much? On secondary side, KVL upon √3, because transformation ratio is what? V phase 2 upon V phase 1. अरे यही होता है, तो ये हो गया. Similarly, phase current will become how much? IL upon K. What will be the line voltage? K times VL. Clear? And line current IL upon K. Similarly, this table you can remember it. Just logic is there. You need not have to cram it. It will be on your tips if you know the relationship between voltage and current in two types of connection, star and delta. Is it clear or not? So here VL, line current will be, sorry, phase current will be IL upon √3. Now phase voltage on secondary side will be how much? K times VL. What about phase current? What is phase current here? IL upon root 3. So it is IL upon root 3. Okay. What about the line voltage? What is line voltage here? What about the phase current? 1 upon root 3. Here also it will be same. Clear or not? Any problem? Now, this is just in a conclusion way. I have given you the where you can go for these two different types of connections. Star star for small high voltage transformer, but is being rarely used. Okay, then comes delta delta for large LV for large LV transformer, okay, where a large unbalanced load is to be handled. Third, star delta, this is being used for power transformer as a step up. Is it clear? For example, at the generating station, when we have to raise the voltage from 11 kilovolt to 400 kilovolt or 220 kilovolt like this, there we go for which connection? Star delta. Is it clear? Then comes delta star. This is very clear for the distribution transformer where 3-4 is for a step down. Basically it is for, हम क्या करते हैं, डिस्ट्रीब्यूट 11 किलो वोल्ट से कितना करते हैं 440 वोल्ट, एंड दैट इज बीइंग सप्लाइड टू द होम्स. क्लियर? ये यूज क्लियर हो गया कि नहीं हो गया? Now fifth type of connection, this is also very important. Okay, it is also called as a open delta. Means you have a delta delta connection and open one winding. So what will happen? For example, like this, I will draw it. Now there will be third winding here. No, there you in delta connection there used to be third winding here. Do you agree? That's how your this winding look like. If I remove this winding, what you will find? This shape looks like what? V. This shape looks like V. That is why it is known as. So winding is open on both the side, primary and secondary side. So either you speak out open delta or you can also say VV connection. You got my point? By the shape it has been named that one winding is being removed or it is open. It is called VV type of connection. Okay. Now why it is being used? As you say that if three single phase transformer are being used, okay, and if one of the transformer is unable to operate, आपने थ्री फेज को ऐसे भी तो बना सकते हैं. कैसे? तीन सिंगल फेज ले लिया. अगर एक ट्रांसफॉर्मर आपका काम नहीं कर रहा है, इज नॉट वर्किंग, देन व्हाट विल हैपन? यू विल लेफ्ट विद टू ट्रांसफॉर्मर. सो नाउ यू हैव ओनली टू सप्लाई, only two single phase supply. Okay, but you have to fed suppose a three phase load, then how will you do it? Then we go for open delta connection. Okay, so cannot be continued with remaining two transfer at the cost of reduced efficiency. However, it can be there, but the efficiency will be reduced. तो अब आप कहेंगे कि मान लो पहले तीन सिंगल फेज ट्रांसफॉर्मर थे तो उनकी 100 एफिशिएंसी थी, अब एक चला गया तो कितनी हो गई? 2/3. 2/3 होनी चाहिए ना, बट नॉट, इट इज नॉट. 2/3 मीन्स 66.66. अरे 2/3 कितना परसेंटेज होगा? मीन्स द ट्रांसफॉर्मर नाउ टू ट्रांसफॉर्मर ऑपरेटिंग एट एफिशिएंसी ऑफ 66. No, this is not there. It will be again a reduced. It is near about 57. It is how much? How much? 57. Okay, how that I will tell you. So how the connections are being made? These are the two transformer. Okay. So what will happen? Now don't go through the 3 single phase. We are making our 3 phase transformer only in the form of VV connection. 3 phase transformer में एक वाइंडिंग हटा दी है, तो हमारे पास कितनी वाइंडिंग बची? 2 वाइंडिंग बची, लेकिन हमारे पास सप्लाई कितने? आर वाई और बी. तो हम क्या करते हैं, ये 2 वाइंडिंग बची ना, तो बी का जो एक वाइंड है वो किसको कनेक्ट कर दिया? सी द कनेक्शन is connected to Y, is connected to the first winding. Okay. अब हम R जनरली पहले हम क्या करते थे, एक वाइंडिंग के एक एंड को R दे दिया, दूसरी वाइंडिंग के एक एंड को Y दे दिया और तीसरी वाइंडिंग को B दे दिया. अब हम क्या करेंगे, जो एक वाइंडिंग है इसके एक एंड को क्या दे दिया? R. दूसरा एंड उसको क्या दे दिया? Y. Instead of connecting it to neutral, instead of connecting to the other, we are given to Y. ठीक है. और इसी Y को हमने जो सेकंड वाइंडिंग है उसके फर्स्ट एंड को कनेक्ट कर दिया, और जो उसका सेकंड एंड है सेकंड वाइंडिंग का उसको कनेक्ट कर दिया B से. Is it clear or not? So in fact we are providing 3 phase supply through 2 windings, not 3 windings. Okay. And similarly, क्योंकि एक उधर भी खराब हो गई, प्राइमरी में भी खराब हो गई और सेकेंडरी भी. लोड भी हमारा कैसा है? 3 फेज. लोड भी कैसा है? 3 फेज. अगेन उधर भी क्या कर दिया हमने, जो सेकेंड वाइंडिंग है वो फर्स्ट वाइंडिंग के एक कॉमन पॉइंट बना दिया, और जो लोड है उसका फर्स्ट फेज इधर, सेकेंड फेज फर्स्ट वाइंडिंग के सेकेंड टर्मिनल पर, और थर्ड फेज सेकेंड वाइंडिंग के second terminal per. In this way your circuit is completed. In this way, on this side also we have a open delta, and on this side also we have a open delta. And how it phasor diagram will look like? This is BYR BYR. अरे समझ में आया कि नहीं आया? Is it clear? मान लो एक वाइंडिंग खराब हो गई, तो हम उसी डेल्टा डेल्टा ट्रांसफॉर्मर को वीवी कनेक्शन में चलाकर हम अपनी सप्लाई कंटिन्यू कर सकते हैं. इज इट क्लियर और नॉट? नाउ द इंपॉर्टेंट पॉइंट विच आई वॉज टेलिंग यू, व्हाट इज दैट? दिस वॉज द डेल्टा डेल्टा कनेक्शन and this is your VV connection. I have already pointed you that in your mind it will click that now the transformer efficiency will be 2/3, but it is not 2/3, that is, it is not 66.67, but it is something more reduced form. What is that? That we have already in delta delta. How much is the power available? √3 times V phase, line voltage multiply by line current into cos phi also. If I take only S, then it will be √3 VL IL. भाई एक्टिव पावर कितना होता है 3 फेज पावर में? What is there? 3 phase power √3 VL IL cos phi. What is S? This is your P. This is your हाँ भावना साहब, मैं 2 मिनट लेकर आ रहा हूं. हाँ so this is P. What is S? √3 VL IL. What is Q? root 3, this is your P, what is Q? Root 3 VL IL sin phi. Are you clear or not? And what is S? Root 3 VL IL. Because S is equal to nothing but P plus minus JQ. S is total or apparent power, P is your active power and Q is your reactive power. In case of single phase it is nothing but VI. S, it is VI cos phi, and what is Q? VI sin phi. In case of three phase circuit, what is S? Root 3 VL IL. What is this? Root 3 VL IL cos phi, and what is Q? Root 3 VL IL sin phi. In fact, the proper definition of the power, active power in three phase circuit in terms of phase voltage is 3 times V phase I phase cos phi. Do you know this? स्टार में क्या होता है? V फेज कितना हो जाता है? रूट 3 VL. अरे होता है कि नहीं होता है? और I फेज कितना ही? यस. व्हाट इज V फेज? VL अपॉन रूट 3. VL upon and IP is equal to IL. When you solve it, it will become root 3. Do you agree or not? And you will get this result. Clear? The same is true for Q also. So likewise it is clear or not? Remember this thing. ये आपके दिमाग में फॉर्मूला हमेशा होना चाहिए, रटने की कोई बात नहीं है. सिंपल, हमको मालूम है 3 फेज है तो 3 पावर होगी, बैलेंस्ड है तो तीनों की कितनी होगी? वीपी आईपी कॉस फाई. 3 है तो कितनी होगी? 3 वीपी आईपी कॉस फाई. अरे होगी कि नहीं होगी? ठीक. बस इसी 3 वीपी आईपी कॉस फाई को मैंने कन्वर्ट कर दिया किसमें? लाइन में. और कितना हो गया? रूट 3 VL IL कॉस फाई. क्लियर? अब ये हम बात जो कर रहे थे, ये इसकी बात कर रहे थे. डेल्टा डेल्टा में कैपेसिटी आ गई, कितनी आई? वही मैंने लिखी थी ना, VLI फेज. ठीक है. अब VV में कितनी आएगी? डेल्टा डेल्टा में कितनी आई? थ्राइस VL I फेज. इन VV कैपेसिटी हाउ मच इट विल बी? अगेन रूट 3 VL IL. Root 3 VL will remain as it is, but IL will become equal to I phase. Now when you divide it, you will get this ratio to be 1 upon root 3, which comes out to be how much? 57 point something, approximately equal to 58%. So a common sense says that it should be 2/3. 3 थे ट्रांसफार्मर, एक हट गया तो कैपेसिटी कितनी होनी चाहिए? 2/3. उसको परसेंटेज में कन्वर्ट करेंगे तो कितना आएगा? 66.67, something like this only. But when we have calculation, we do the transformer is operating at a reduced capacity of 58% rather than 66.67 or whatever it may be. It is 58.7, I think so. Correction is there. It is 58.7. You got my point? So basically it is 57, not 58, 57. So it will come out to be how much? 57.7. That is approximately 58%. You got my point? Mathematically is clear. So in examination you can be asked, prove that the Scott connection, sorry, the VV connection operates at a reduced capacity of 58%. So you can just do this calculation. Clear? So tomorrow what we will do, we will take another we will take numerical of this Scott this VV connection, and lastly the Scott connection. Clear?